Good evening, all. Hope you all doing well. We will start for today. Shashank sir, you can take over the class.
Sure, ma'am. I'll start. Thank you. So good evening, everyone. Let us start the session. So yesterday we were discussing a project, right? So we have taken up a big project and we were discussing that. So let us continue and understand, right? So what is happening inside the project and how we, cluster and do the recommendation systems. So let me share my screen. Just give me a minute. Yeah, good evening. Yes. So this is what we were discussing yesterday. Okay. So customer segmentation and recommendation system, right? When we started this, I'll give a brief, thing what we have discussed yesterday, and then I'll continue from uh, where we have to, continue from where. So just a brief glimpse I'll give. Okay. Uh, so what this project is about, handling the customers, okay, and how to sell them more products because this is basically this is basically based upon selling, right? It's an online retail store. So right, so any retail store will have the same kind of similar kind of analysis, and that's how they actually proceed to sell products to the customers. So on that note, what we have actually seen is we have seen the online retail data for the UK based company. Okay, so the transactional data. And now we have applied that. We'll process these 6 steps in identifying the correct recommendations for the right amount of customers. And we have imported the libraries and we have applied some of the configurations as well. And then we have went through the data set and what is the description part in the data set as well. So after that, we have seen the head of the data and then the info, which gives the null count, all those things. And we have identified that there are a few null values. And then we have seen what is the inference from the small analysis what we have done. And then we have used the describe function, right? So all these things we have discussed already discussed yesterday. So and then we have used for the objects how to use the describe function, and we have made an inference that what has happened. So we have identified some of the small loopholes in the data set. And we try to identify the missing values, right? So mostly the missing values are in two columns, or the record, I can say the features, which is customer ID and description. So since the ID is a very important part and it's missing, so we thought to delete that 1/4 of the data, right? Nearly a quarter of a data is missing. So we have chosen to delete that because we felt it's a somewhat a better or a safer option if we do that. So after so after that, we have gone through the very important part, identifying the whatever is having null. And we next step is we started identifying the duplicate rows, right? So what are the duplicate rows what we have or records in the data set? And we try to handle those duplicates as well. So after that, we try to edit, we see the shape. So from 5.5, around 5.4 lakh, I guess. So from there, it came down to 4 lakh. And then we started identifying based on the cancelled or completed status, which has C. So that is the transaction or the the order has been cancelled. Okay, so we cannot do analysis for the cancelled, but we can understand what could be the potential reasons for cancellation of data. Sorry, cancellation of the products, right? So we can also understand the customer's behavior also when we identify the cancelled products. So that is what we started to do also. So on that basis, we planned a strategy to handle the cancelled transactions. So next is to identify how much of cancelled transactions. It's coming around some 2% of the data. Okay. Then we tried identifying the unique things, then the topmost things by plotting the graph. So the most frequent stock codes we have started identifying. So then after that, we have counted how many letters for the stock code. So by that we can identify that there is an issue with this because stock code cannot be 0 or 1. So we have made changes accordingly, right? And then we have identified the anomalies because these stock codes are basically the anonymous. So which are not supposed to be. So there is an issue. So we try to we can actually delete them. So then going forward, we try to after checking or doing with that, I can say handling with that. That's a correct word. So handling with that, we have checked the shape of the data. It's around almost 4 lakh. Okay, 3.9. I can say 3,99,689. So after that, we have seen the value counts for the top 30 descriptions of the products. Okay, so that we have identified. So you can also see that this white hanging heart t-shirt holder was the most frequent description, which is actually which kind of product which has been bought. So after that, we have identified the lowercase part and uppercase part. So this also we have completed, right? So how many because having the words like that is not a correct way. So we try to identify where we have lowercase, but we can only see at this gram, centimeters and all. So we try to handle that as well. Okay, so we try to handle those part of how we can convert them. Okay, and then we have seen this unit price. Okay, so I think we have completed till here. Yeah, even this part also done. For the unit price, we have also seen that what is this minimum? Yeah. So what is this minimum zero for the unit price also we have seen, right? So because a product cannot be, unit price cannot be zero, right? So potentially it's a data entry error, right? So we try to handle that, and then we strategized, keep the products which is having greater than zero. Okay, so so we dropped the unit prices which are less than zero. Okay, so we handled that. So I think till there we have actually stopped. Now, there is one important concept, before starting today, which is this RFM. Okay, that's why I've stopped here exactly to understand, because there are certain elements which need to be understood, in management perspective as well. Because this customer engagement and all is very important to make sure how we actually give preferences and treat the customers. So this RFM is basically a method which is used to analyze the customer's behavior, right? So how the customers, show interest in buying the products and how they behave, we are going to identify. So the first one in the RFM is the R, which is the recency, right? So this is a metric which is actually or you can say it measures how recently a customer has made a purchase. Okay. So lower recency means the person is actually showing more interest and he's buying more products, and there is a lot of customer engagement or higher engagement with the brand. Okay, so we try to understand that it's been how many days that a customer has purchased uh, our product, and then comes the frequency, which shows the how often the customer actually, the metrics basically significance the higher frequency of a customer, how a particular product, how many times he's actually buying. Okay, So that means he's very loyal customer and he's showing a lot of interest in that particular product. So, the company can, when they group these kind of people, they can identify that, okay, so, these people show a lot of interest in our product, and these people actually have a lot of interest to buy our product. So they are loyal customers. So, the company has to, maintain, or we can say, they can actually show some intent to retain those customers which have who are very loyal and showing a lot of interest also to buy the products. So next is the monetary part, which is the amount part. So how much of money the person has spent, right, in a certain, how much of money a person has spent in a certain period, or how much of contribution is doing for the business. So next is, in that aspect, we are trying to identify and we are trying to analyze based on the last purchase. Okay. Uh, Actually, somebody has raised a hand. You can just put a message if you have any doubt or a question. Just take up. Okay, fine. I have not received any question. You have raised a hand, so maybe thought you have a doubt. Can just post the question in the chat if you have any doubt, or you want to ask me something related to our project, or something related to machine learning. So fine. Okay, so let me continue. Okay, we have less time, so we have to discuss a lot of things. Okay, so next thing is days since the last purchase. Okay, so here we are trying to understand that how many days it's been the customer's last purchase he has done, right? So it is basically to understand how the customer engagement is there. So this is what our main focus is. Okay, now let us do that by using the invoice date. Okay, so the next part basically is to convert the invoice date, right? So it is to understand that how much of time he has been spent, or when is the last purchase a customer made on a certain product. So what we can exactly extract is how many days it's been that that particular person has made that purchase. So this is the code where we can actually, it's a very simple code which I have mentioned to identify, and we also have mentioned here, this is very important. So drop the rows which actually are having invalid dates. Okay. That means it might be an error in, it might be error in different ways. Okay. So it can be an error in a different ways. So it is very important for us to identify that that what are the dates which are valid dates, and to identify that how we can proceed with the dates, and how we can identify the customer. So that is what we are trying to do here. Okay, so we have identified, already that we have identified, and we have kept it in the memory. Okay, now let us go to the now this customer data basically contains the days since the last purchase. Okay, now let us see the head of the data set. Okay, so here you can see that this customer ID, if I just print the top five, it's showing that with the customer ID, right? With this customer ID, this man has made purchase 325 days ago. This person has made 2 days ago, 75 days ago, 18 days ago, and 310 days ago. So it's just the first five observations. If you want, you can print the entire data, or you can just print the first 10 observations. Okay. So no use of printing the entire data, because we are not going to go through read, and we are not going to make any inference. That is why we are using Python coding, and we are trying to do the analysis using machine learning. right? So just to sample to see that it's just a sample actually to see that we are we are just what we have done is that actually translating into the outcome, or is it we are able to do that particular conversion into a variable what we require, right? So to identify that, we just put the head of the data. Okay, so just like when you import the data, head doesn't actually, we already know the data. It is just to make sure that you can see the data what you have imported. That's it. It's not like whether what is the use of seeing the first five, nothing. Just to understand that yes, the data is actually loaded into the data frame. Okay, it is working. Okay, you can see the entire data in the Excel sheet only. Why do you want to see the first five observations? So here also we have done a certain thing, and on that certain thing, whether it is working or not, we are going to check. Okay. Now let us go forward. Okay. So the next thing what we are going to do is we are going to use two things now. One is the total transactions and one is the total products purchased. Okay. So now the same thing what we have done here, what exactly we have done is we have converted, the person's record. I can say the, based on customer ID. Okay. So we have converted that how much of time that that particular customer has taken since the last purchase, whether it is 2 days or 5 days or 10 days or 100 days and so on. So the next part is also very important. The next part, what we are trying to do is we are going to convert into the total transactions made by the customer. Okay. So in the entire data set, how many of transactions he has made and how many total products actually he has purchased. Okay, so this is very important. Days since his last purchase. Along with that, we also need how many transactions that fellow has done or that person has done, along with the total products he has actually purchased. So in that quest of identifying this, we are using grouping the customers. So group by is a function which will group the customers who on their customer ID who has made the total transactions. Okay, so it will identify using the invoice number. So all the unique invoices we are taking. So unique invoices indicate that they are the total transactions. Why a unique invoice? Because it might be 5 products he would have ordered at one go, and all the 5 will have the same invoice, right? So you cannot count it as 5 transactions. You can count it as one transaction, right? He has ordered 5 products. We are counting the number of transactions. Okay, it's not the number of products we are counting. We are counting the number of transactions. Okay, after that we are counting the total number of products. Okay, so that is why in the quantity we are summing the products, or we are adding up the products. Okay, so it will give you sorry, it will give you the total number of products what that particular man has, or the person has purchased. So now if you print the head of the data, we can see that you can I have bought this this customer underscore data, where you can see that how many days it's been since his last purchase. Along with that, I also bought that what is the total transactions that person has made and the total number of products he has actually bought. See here, the total number of transactions he has made is only 7, but the total products he purchased is around 2000. So he would have ordered some 400-500 products at one go also, right? So now if I have to understand through my analysis or what has happened in the data set till now, so this is what actually I have done. So I've converted the days since the last purchase and the total transactions and the total products what actually we have done. Next is the third important aspect is the total spend, right? And the average transaction value. So per transaction, how much of amount that particular person is spending, and on a total, how much of money he has actually spent. That means the unit price and the number of quantity. So if you just calculate that, you are going to get the total spend, right? So here To simply calculate that, we are using the formula unit price into the quantity. So for example, each unit is $10. So 10, so UK data, so it's pounds. So a particular product, one unit is 10 pounds. So if I has purchased 10 units of one product, so it will be 100 pounds. So it's just a multiplication. So here we are trying to calculate the total spend by just giving the formula that it has to be multiplied, right? So after that, we are grouping the customers, right? We are summing them and grouping them. So this group by will actually group the customers. So after that, there is one more thing which is the which is used for calculating the average transaction. So for average transaction, we have actually given a formula. You can see it here, right? Which is basically the average of the total spend divided by the average of the total transactions. So it will give you the total average transaction value, okay, for the for the customers, or you can say average how much of amount a person has actually spent on each transaction, right? So now with the now we are merging that also, right, with the above data set what we have got. So the above one, actually the first data is up with the days since his last purchase. So we have merged this data frame with this next piece of code where it is actually merged with the total transactions and the total products purchased. So after that, we are also merging these two things, which is the total spend and the average transaction value. This code is basically for merging, okay, with the previous table. So now what happens? We will get the entire table where you can see that the days since the last purchase, then the total transactions, then the total products purchased, then the total spend and the average transaction value. So this is what actually happens. Now, let us go to the next part, right? We are adding one more, which is the unique products purchased. Now, for that, we are using a formula, again, n unique. So already you would have, by this time, you would have understood that in the stock code, if you give the n unique function, automatically it will pick the unique codes which have been processed or which have been purchased by the customer. Okay. So if we implement this, again, we are going to merge with the data set what we have actually given before. So now, again, if we print the head of the data, you can see that the last purchase, that's what we started with. Then we added the total transactions. Then we added the total purchase. Then we added the total spend. Then the average transaction value, right? And then we have added the unique products purchased also. How many of unique products that particular person has purchased with this customer ID? Okay, so we have done a lot of things till now. Now, next, let us see that what has happened with the other part of the data. Now, to understand now even the customer behavior, the most important thing is on which day that particular person is actually doing the shopping. Okay, so what is the favorite day of the customer who wants to do the shopping? Okay, that is a very important thing. And also we have to identify that what is the average days between the purchases. For example, I have made two transactions. So what is the average time I have taken to do a transaction? Once I've done the first transaction to the second transaction, what is the average days I have I had in the middle? For example, I'm doing after 7 days, or if I'm doing after 10 days, or if I'm doing after 2 days, or I'm taking a month. So that is very important to understand the customer's behavior. How often a customer is going to purchase a product, right? How often a customer is going to purchase a product, and which day customers are showing a lot of interest to purchase a product. So that is also a very important aspect. And after apart from that, we can also identify that what is the favorite hour, or which is the favorite time for the customers who wants to make a purchase. That is why our data is being collected with the date as well as the time frame. So when we are having this, we can identify that what is the average time he has between the purchases, and what is the favorite day the customer wants to purchase a product, and what is the favorite hour or time frame where the customer wants to show interest to purchase a product. Okay, so this is what we can identify. So now coming to the that part, we are creating obviously to extract the date, we use this function which is day of the week. Okay, so this will convert into days and hours. Okay, so here we are using the functions. Okay, so these are basically the lambda functions which we use to calculate the averages in this case. Okay, so we are calculating the average, and it's not just about average. We are all sorry, we are also grouping the customers. This is very important to understand that what we are exactly trying to do here. We are trying to group the customers on a particular basis, right? So to identify that, what is the time frame between the transactions. So how you group a customers, we should use the customer ID, correct? No, and we have to know that on which day he has made the invoice, right? So then only we'll be able to identify, and we are able to, then we are calculating the mean value. You can see. So based on the grouping by, we are going to calculate the mean value, which will give you the average purchase between the, so I can say average days between the purchases. Okay. So how often the customer, see, why this is very important is we can understand how, which group of customers are making a purchase every week once, or once, or every 2 days once. Okay, so we can extract information in such a way that how that person is impacted on the products we sell, right? And how much of impact we are having, we are creating him, or how much of interest we are making him to search our particular website and search for products, right? Because every not, if not every day, there will be every month at least some 4 or 5 times you want to order certain products from online retail, right? Because in Flipkart or Amazon, right, in India we order certain products, right? Household products, or baking products, and so on. There are many products which we ordered, right? So when these online e-commerce have started, a lot of things which we can purchase outside also, we are ordering it, because there are many factors in that. So it might be the product comes to our home, right, without we actually going, and also the price of the product. So so it is very key where the people, how often a person is actually purchasing a product. It is very important for us to understand as well, right? So okay, so it is very important that how often we certain group of customers are ordering the particular product, right? Maybe they're taking a week, every week they are purchasing. Maybe they are free on Sunday, so they just sit for an hour or so and search for the products, right? So if you can understand that that this particular people, this group of people, that is why clustering is very important. People take clustering as a very light concept. I've seen when I've taught multiple places, I've understood that people take clustering very lightly. Clustering, not what is it? Just grouping. No, it's not just grouping. Please understand this. Particularly in certain areas, particularly for marketing, right? The products, and giving the customer what we want, we have to identify the correct clusters or the correct grouping. That is in where the customer, the clustering and the recommendation systems plays a very, very important role. So it is very important to understand the right customer, and give him what he wants, right? So happy customer, definitely he'll come back buying your products. Obviously it will turn in turn into a good business. So that is why we have to identify that what is his favorite day of shopping, right? How many days he takes. Based on that, we can suggest him a lot of products, right? So if you see on a day-to-day basis, Amazon and Flipkart, they suggest you a lot of products which is in your wish list. You get a notification that the price is reduced, right? And this particular product is in stock, right? We have some offer on this product. We have a bank offer. Why these things are coming? Because they are grouping the customers. Which kind of customer wants which kind of thing. So, when you get notifications, maybe you'll just have a look and feel that, oh, this product is actually good, right? And, it has been in my wish list for a long time, and, I want to purchase this product, right? So that will in turn make you to buy that product because you need that product some way or the other. That is why it was in your wish list. So, you just buy the product and it will be business for the the online platform, Amazon or Flipkart, or it is business for the, and it is also business for the company. So this is how things work in the reality. So that is why we need the customer segmentation, which is a very, 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 very important concept in my opinion, in the entire machine learning. I give first preference to, this kind of projects, right? So because it is very important when it comes to the products, particularly these e-commerce, things and, what we purchase online as well. So it is very important because we do a lot of shopping through online things. So coming back to our project, so that is where it is very important for us to identify that which, how much of days that, that it is taking between the consecutive purchases. And apart from that, what is the favorite day as well as, so here you can see the count of days. Okay. It will actually give you the total number of counts that, how much of time it actually takes or how many products have been sold on which kind of day, how many people are showing interest to buy products on which kind of day. And then the shopping hour, maybe they're free in the evening, so you can push out suggestions and all if they're free in the evening, if they're free in the morning, or they're free in the afternoon. So if they're free at night time, so you can push notifications. You can so you can, because these notifications and all are basically automated, right? So we use automation for that. So no, a person is not going to sit there and, send the notifications on an individual basis. But at least to send notifications or suggestions to the customers, you have to know which customer is showing preference, right? So you can't simply just send to everybody, it's not possible. So you have to pick the right customers. That is why we segment the customers and try to identify them. So this is the whole picture, of this data set and what actually we encounter in real life. So I'm just trying to build the connection between what exactly happens, in the real time, as well as what is happening in our data set and how this we can link to our real life, real life projects, and how we can actually build upon and how much we can actually, do these projects. So it is very important to understand it. Just give me a minute. So fine. So let me continue. Next part is once this is done, we are going to merge with the customer underscore data. Okay. So now what we are merging already, we have days, transactions, purchases, spend, all everything. And what we have actually added is we are going to add also the average days between purchases for this customer ID. Okay. So for this customer ID, there is average days. Okay. So it is 2 days here, 10 days here, 0 days here, right? And day of the week also, and hours, okay, which hour he prefers. So 10 is basically 10 o'clock in the morning, 14 indicates 2 o'clock in the afternoon, and 19 indicates 7 o'clock, and again 9 morning, and so on. Okay, so coming to the next part, which is the country, right? And most of the data set is basically based upon UK because it's a mostly UK based, project, right? So it's basically, the people or the customers who are mostly based upon UK. So here you can see almost 90% of the data is from the UK. Then we have total of other five. Totally, we have 1, 2, 3, 4, 5 countries together, right? So it is basically Spain, ID, and France, Germany. Okay. Right. So the next part is, that's what the inference is about. So 89% of the transactions are from the United Kingdom. So next part is grouping the customers, right? Next, what we are trying to do is we are trying to group the customers based upon the customer ID and the country. and we can identify that how many transactions per country has been made. So here in this case, actually the more transactions will be from the UK because it's mostly about the UK data. Okay. Then we'll try to identify each customer that from which country has done the maximum transactions and so on. Okay. So now what is the next part? What we are going to do is we are going to add, you know, right? We are going to add this column, which is UK or not. Okay, that particular person is from UK or not. Okay, so if that particular value is equal to the United Kingdom, give it one. Okay, so I'm just I can say I'm basically encoding it. Okay, one hot encoding. So I'm giving whichever is UK. So give it as one. Okay, so give it as one. And if it is not UK, give it as zero. Okay, so if you see wherever you see zero, you can identify that that person is not from UK. And because more is from UK, so I've segregated into two parts. So one is UK and one is non-UK. So the person, if it is from UK, it will be given one. And if the person is not from the United Kingdom, it will give zero. So when we go to the next part, so if see the customer IDs and the total value counts, I can see that there are, the customer data. Then more the UK people, the UK customer IDs are basically 3866 and non-UK are 416. Okay. So next is the let us identify the cancellation frequency and the cancellation rates. Okay. So this is also very important. So it's not just about it is not just about understanding that okay, how much of purchases are being made. Also, we have to understand why a particular person is canceling the products, right? So what is the reason for it, right? So maybe he is not he is not satisfied with the reviews, or maybe he has got a better deal. So, if you try to understand that what is the reason that a person is actually canceling the products, we can identify that what is the reason and what could be the potential reasons, and what or how we could act actually on we could act on that actually, and based on that we can make a move, right? And we can make a move and try to understand that what my customer needs or what my customer actually requires, what my customer wants, how can I give him and how can I make him buy the product, right? And not to cancel it, right? So that how I can improve my customer experience by by helping the customer that he doesn't cancel the transactions. So this is what we are going to try to analyze. So that is what the behavior of the customers we are trying to analyze. So if you have any questions, you can just post. I'll just give a couple of minutes. So if you have anything, we can just discuss. Okay. So I've not given much time till now. We have a lot of project also to discuss. So maybe we can take a 2-3 minutes, quick 2-3 minutes. If you have any queries, we can just this I will share once the project is done. I thought to share this file. Okay. So data set I have given, but uh, I can say this Python coding I have not given. I'll share this today. Once the session is done, I'll share this. Data set. Okay. You want now itself? Uh, okay. So just give me a minute. Just give me a minute. Um, I've shared yesterday online retail. Yeah. Yeah. So this is the data set. Actually, I've shared the data sets drive link also. Whatever data sets I'm sharing, I'll put it in this drive link. Maybe you can use this drive link only. Okay. So in that drive link, this online retail is also there. So the data sets what we have used till now: employee attrition rate data, housing data, online fraud, and then online retail. So everything I have shared. Uh, in this drive link. So maybe you can save this datasets drive link. So in that, I'll also upload the certain datasets, whatever we are discussing, I'll upload that as well. So it will help you also to, do the practice part as well. So I think, that's what the same link shared. The above link is directly to take you to the data set, but the second link what I've shared gives you the folder. So yeah, you can just bookmark that folder link. Uh, just open it and give it a bookmark. So throughout till the end of the sessions, I'll share the data sets there, so you can actually use it for the future purposes also. So any good data sets also I'll share. Even in future, you can use those data sets if you have the drive link. So it's my personal drive link only. So I'll be uploading data sets. You can just use the data sets, whatever, because I also try to explore good data sets and use it for understanding the real-time projects and all those things. So it is very important. So we use a very good data set which helps us to learn and grow. So you can use that. Yeah. So any question regarding anything you can ask me. Sorry. I think we can continue. Not much questions, only on this. Okay. So let me continue. I think not many questions. It's good to go. Fine. So let us continue on this. Okay. So here, what we're trying to understand is the cancellation frequency of a certain customer and the cancellation rate. So how many, or I can say how much a proportion of cancellations the person is actually trying to do. So what will happen is it will make sure or make us to understand that if a person is canceling the products more often than not, that means he's a dissatisfied customer, right? So he's not satisfied with the products, what maybe customer service or the products what actually being delivered. So we can actually target them to understand that, right? Why, what is the experience or what is the difficulty they are facing in, they had to cancel the products, right? So we can understand that, and we can also identify the total number of transactions that a person has actually cancelled. So what could be the potential reason that he has actually done it? Okay. So now let us go forward. So in that process, what exactly we are trying to do is, let me show you the, uh, you know, so this is what we are going to create. So cancellation frequency and the cancellation rate. Now to do that, how we are going to proceed with the coding part is, we are going to identify, right, the transaction status as cancelled. Okay. So for that, we are going to identify by grouping of customer ID and the invoice number. So if we do that, it will automatically, using the end unique function, it will uniquely identify what are the unique things in the customer ID and the invoice. So in that, I'm going to identify whether the transaction status is going to be cancelled or not. So in that cancelled frequency, I'm going to create that whatever is cancelled, right? It is going to identify that, cancelled frequency divided by the total number of transactions in the invoice. Okay, so it will give you the, the transaction, sorry, the cancellation number. Okay, so it will give number of cancellation frequency very less. Okay, cancel. This is the average. This is the rate in which he is cancelling. Okay, so that will be identified per customer. Okay, so now going forward, next, we are going to identify this monthly spend. Okay. So what is the average monthly spend that particular customer is doing on that product? Okay. So what is the mean? What is the standard deviation? And let us also understand how the trend that a particular customer is actually spending over the time. So is his trend going up? Is he spending more, or is he spending on a consistent basis? Right. So maybe the trend is little less or it is going high. So we have to understand or identify that part also, that how the customer is actually spending his money, right? So we'll try to identify that by using the date and year function. Okay. So if we identify, because if we use this date and time month function, this becomes a time series data, because since we are analyzing the date along with the date and time, obviously this data becomes a time series data. So that is why even the date and time is also captured when you do the online transactions in any of the e-commerce. So because that also will be analyzed. So like how we are analyzing now, right? So we are trying to understand by the date and time that, average time spent between the, purchases, all these things we are trying to understand, right? So that can be understood by, by grouping the customers, that how the customers actually behave in their online purchases. So here you can see that, based upon their year and month, they're identifying, they're summing the total spend, what they're trying to do. Okay. So after that, they're going to calculate the aggregations, which are the mean and the standard deviation. So we are trying to calculate the mean as well as the standard deviation. Along with that, we are going to calculate the trend in the data. So this trend will identify by using the linear regression. Okay. So it will draw you how the data is actually, processed, or how the, customers are buying the products. So you can get a linear regression trend, or you can get the trend line by using the linear regression. So that is what we are trying to do. And after that, we are trying to merge the data set with the original data set of the customer underscore data. So now we will have more columns. After this is UK cancellation frequency. Now, what is the things we have added here? You can see that we are calculating the monthly spending, right? Seasonal buying spending. Okay, so that is what we are actually identifying. So monthly spending mean value, right? So this fellow is monthly spending around 615 pounds. So this fellow is around, or this person is around 359 pounds. This person is around 1457 pounds. Okay, so we'll be knowing that how much, and this fellow is having a, these people are having a standard deviation of 0, 0, 0, and here 203, and and spending trend, whether he's having a positive trend or a negative trend. Okay, so we can also try to identify. So we'll be knowing that how the customer is actually behaving. Okay, right. So now let us go a little forward to identify the unique. So now what we are going to do is we are going to change the data type of the customer ID. Okay. Now to string to as a unique identifier. Okay, which is not used in the mathematical operations. So we are going to convert the data type of the customer data. Now, let us convert particularly the customer ID column. Okay. So after converting, what will happen is this customer ID, instead of integer, it becomes a string. So I'll tell you why we have converted. Okay. So this is the customer data, and these are the columns what we have actually created. So these are not the columns in the original data set. These are the columns what we created, in the analysis, what we have done, what we have understood today. So we have seen the days since the last purchase, total transactions, total products purchased, total spend, average transactions, all these things which we have created today, right? So in the analysis, what we have done, which are not part of the original data. So we try to understand the behavior of the customer by creating some additional columns. And in that, we have taken a particular variable called as customer underscore data. So in that customer underscore data, we have created these particular features or attributes or columns to understand the customer's behavior. So now let us review what are the things what we have done. Okay, so these are the 16 columns what we actually have, excluding the customer ID. I can say 15 columns what we have created, or features what we have created. Now this basically, I need not again go through. That is what I feel, because already we have discussed, at each step what that particular column, why it is existing inside the data set. So you can just have a look that what each column actually tells us, which we have created. So I hope you have just gone through the columns. So anyway, all these columns we have discussed, so you'll be remembering. But I just wanted you to, just read to understand. Okay. Okay. So let me continue. Next. So what we are going to do is now we are going to we have made a certain features, or we have made a certain adjustments in the data set. Now what we'll try to identify is, let us try to use the very important aspect here, which is the usage of the isolation forest. Okay, so this isolation forest is basically is used, I would say, it's basically used to identify the outliers in the data, right? And also the anomalies in the data, which actually, you know, help us to understand more. I think I got a question. Okay, attendance. I can see a question from Syed sir. Syed sir or student, not sure. Unique and n-unique. It is actually, to in a simple way to answer what is the difference between unique and n-unique. So unique actually gives you the arrays. Sorry. It gives you the array of the unique customers or unique things in a particular column. N-unique will give you the number of unique things. It will give you the number. So, for example, there are 10 unique things. A unique function will give you that 10 whatever are there. So n unique will give you the number of unique things. Like it will give the number 10. There are 10 unique things. So that is why that n is there. N indicates the number of unique things. And unique indicates an array or a list of all the unique elements. Yeah, I hope I've answered your question. So next, any other questions you have? I think no, just ma'am has posted the attendance. Okay. Fine. So let us proceed with the project. We have so many things still to discuss in this. Okay. So now what we are trying to do is we are going to apply the isolation forest. Okay. So there is something called as a contamination parameter. Okay. So what happens here, I have clearly mentioned, right? So this is basically to observe the data by splitting the data. So that is what the main focus of the isolation forest is about. So now for that, what we are trying to do is we are going to identify the customers. We are going to fit the data using the isolation forest model. Okay. So isolation forest model, what it does is it will try to I can show you the output here. See. Okay. So what happens is it will identify, it's a very, very good, method, I would say, to identify the outliers, or I can say anomalies, right? Right. So now what it is going to do is I'm going to identify, I'm going to predict the model, right, for the customer data. Okay. So I'm going to convert into a NumPy. That means arrays. Okay. So I'm going to create a particular column, right? So how that column is created is that, if a particular, if that particular value is equal to -1, x is equal to -1. Okay. So, give 1, right? If that particular value is equal to -1, and or if it is 0, okay, give it as 0. So that will help you to identify the outliers. Okay. So now once we apply that, what is the next part? What we can understand is what we, after applying this isolation forest, we have identified the outliers and marked them into a new column. Obviously, we have created a new column. So we also have calculated the outlier scores, which represent the anomalies of each record. So now let us visualize this. Okay. So now let us visualize this. Okay. So let us create a plot. Okay. So here we can create a plot, right? So I'm creating a bar plot, okay, which is a horizontal bar plot. Bar H is nothing but the horizontal bar plot. So now I am just converting or identifying the outliers. Okay. So if I plot it on the graph. Okay. So what I understood is there are 94.98% of inliners. Okay. And 5% of outliers. See. From the above plot, we can understand that 5% of the customers have been identified as outliers. So isolation forest is very good in identifying the outliers and the anomalies in the data. So now in the entire data, with a simple syntax, right? just by using the isolation forest, right? And the model prediction using the isolation forest and just using a if function, if else function, you can classify the outliers and the inliners. Okay. So, and we have plotted the graph with a simple, bar chart. Okay. So once we have done this, it is, we also have given the value counts to count and create a percentage. Okay. So it has created around 95%, I would say, are the inliners and 5% are the outliers in the data. Okay. So after this, if plot, you can see that this is what the inference is about. The percentage actually seems to be in the reasonable proportion, not too high to lose a significant amount of data. Okay, and not too low to retain the potential noisy data points. So it suggests that our isolation forest algorithm has worked well in identifying a moderate percentage of outliers, which is very crucial or critical in refining our customer segmentation. Okay, so now how to proceed further now? So now let us understand, after identifying using the isolation forest, what is the next thing we are going to do is we are going to identify using the clustering. Okay, so to do this part, it is very important that we handle these outliers. So now what we are going to do is we are going to separate the identified outliers. Okay, based on our proposal or our requirement, we can strategize, we can drop them or we can delete them or remove them from the data. So what we are going to do is what we will do is let us not draw for the time being. So what I thought is what can be done is a very good thing is to segregate the data. So what I'm trying to do is I'm going to segregate the data into the data with the outliers and the data without the outliers. So I'm segregating the data into 95% of the data which is doesn't have any outliers, and 5% of the data. So I'm dividing the data into two parts. Okay, so which is having one is the outlier which is classified into one data 2, and data 1 will be the cleaned data which is consisting of the data which is not having an outlier. So if there is a measure called as an outlier, right? So it is an, if it is equal, it's a cleaned data. Okay. Sorry, it's okay. Now, if I just go to the next part, so let us see the customer data with the cleaned shape. Okay. Now, let us try to put a correlation matrix. Okay, that is our, we have a little speed up on the project. So let us, set a style, and this is white grid is, up to you, optional. Okay. So this white grid, okay, this style is particularly optional. So if you don't give this, you will cannot get the grid. If you want a grid, you can put the grid. So now what I'm trying to do is I'm going to apply the correlation matrix, right? And I'm going to check whether what is the correlation between the variables. Okay. So understanding the correlation between the variables, I think you can easily do. So I'm just moving forward with this part. So now, just the inference part, I have a, just have a discussion. Okay. So since everybody knows what is a correlation basically is, but maybe visualization, maybe you would have not have done. Okay. Some people would have done with the visualization, some might not have done. So here you can see that what are the instances which are having the high correlations. Okay, so it is very difficult if there is a high correlation between the values or the attributes, right? So it is very important that we try to reduce the correlation. Okay, because what happens is we might get the multicollinearity aspect, which shows the high correlation between the independent variables. So to handle that, what we do is we apply the PCA method, which is the principal component analysis, right? So PCA is a method where it aims to calculate the eigenvalues and the eigenvectors, right? And it tries to reduce the uh, dimension in the data, right? It tries to identify which are the factors are contributing more to the target variable, and it will remove, we can remove that it will be actually showing the direction where the data is contributing more. Okay, so let us apply the PCA part. Okay, and before that, what we are trying to do is this is a very important methodology. Okay, so I just move this particular part little faster. Okay, because we have a little time constraint as well. But this methodology I want to discuss because this is very important. Okay, I cannot skip this. So to balance or to have to understand how the actually data actually works, the most important thing is we have to transform the data, right? So how do we do that? We apply the standard scalar. Okay, so if I just show you this here, you can understand, right? So standard scalar is basically a method which is used for scaling. Okay, so scaling is nothing but bringing on the same page. Okay, so we apply the normal distribution techniques as well. So here we are applying the for standard scalar, we use the normal distribution pattern, which is to standardize. So that is basically using the creating the mean 0 as well as the standard deviation 1. So here, for the customer ID, we cannot do that. Okay. And for is UK and day of the week, we cannot do this. Okay. So what we do is we try to give them encoding, right? So particularly for day of the week, we can give the encoding from 1 to 7. Okay, so what we try to do is we try to because only standard scalar can be done on the numerical values, right? It cannot be done on the categorical values. So for example, customer doing even the customer ID is a numerical value. It doesn't make sense to do the uh, scaling or the standard scalar on the customer ID, right? And on is UK and day of the week, we are excluding that these doesn't come under the scaling. Okay, so after that we scale them and we transform, right? Now we can see that the values are different from what we had in the previous data. So these are all scaled values. So why need dimensionality reduction? Okay, I'm not going to uh, dig deep. But the most important part why to need dimensionality reduction is so that the multicollinearity is reduced. Okay, and if there is what is basically multicollinearity, as I already told you, it is basically a measure to identify that the correlation to reduce the correlation between the independent variables. So what happens if in the independent variables are correlated more, the decision making becomes very difficult. So that which particular column or which feature is contributing more to the outcome variable. So to make or to be cautious on this particular aspect that this doesn't happen, right? It is very important for us to focus on this dimensionality reduction where we try to reduce the noise in the data as well as the high amount of correlation between the independent variables. So this is the main agenda of using this dimensionality reduction. So next, if we go down, so there are many methods where we apply the PCA, okay, or the principal component analysis. Okay, in that, there are many methods, as I already told you. The main important method which I'll be focusing on is the principal component analysis, which is the PCA. Okay, so we will just go through this later part, how this PCA works and all those things. Okay, coming to the next part, we are applying the PCA. Okay, so principal component analysis is where you need not understand how that actually applies. Okay, so if you have interest, you can just focus more on how PCA works and all, because a lot of mathematical stuff is involved. How the principal component analysis works. It actually uses the covariance matrix, eigenvalues, eigenvectors. So it is purely mathematical and statistical. So if you have interest, you can explore that part of how PCA actually works. So if you have to apply it in Python, the implementation part is very simple. Okay. So the implementation part is basically to fit the PCA into the scaled data, what we have created, and we are plotting the graph. So once the graph, let me go to the graph first. Okay. So you can see that there is two components in the graph. So one is the number of components and, two parts in the graph, which is number of components. And the next thing is the explained variable. Okay. So if you see here, there is an optimum value of k, which is 6. Okay, that is in where both the you know uh, things are passing by. Now, if you see that how much is getting explained. So if you take the first six variables, it is actually explaining about 81% about the data. Ideally, if you ask me, I want at least some 90%, uh, you know, 95% actually is the industry benchmark, where if you apply the PCA, at least 95% of the data has to be explained by the variables. You can include that number of variables. But here you can see some 80%, that is what it is actually telling you. So here, that is what this inference is also about. So the six components, okay, the six components are capturing about 81% of the total variance. Okay, so that is why we have to do the PCA. So it actually helps you to reduce the dimensions. Okay, so here now what, since 80%, almost 81%, actually this is not a very ideal number. Okay, ideally we want around 90-95%, but sometimes we have to compromise on certain things. Okay, so the first component explains about 28%, the first two about 60%, like that I have given. Okay, so we cannot go with 28%, 49%, even 81% is low in my opinion, actually, to be fair. So, okay, so, just to, just try to move forward and understand. So what happens if I, capture this 81% of the, uh, total variance in the data set using the six components, first six components, what are there? So, this particular syntax is very important because if you use this particular syntax and use the bar plot to plot using line plot and bar plot to plot this particular principal component analysis on the graph, this tells you that how much of percentage is explained by each component. Okay, so that is in where it is very important that you'll be able to figure it out which particular feature or which particular component is basically explaining you about your outcome variable. Okay, so it is very important. So please keep this in mind. So since we have taken the conclusion where the first six components are basically explaining the 81% of the variance, let us move forward by taking those six. Okay. So let us see. Let us actually use those first six components, and let us see the head of the data set. So this is the six components which their principal components have been applied, which is the PC1, PC2, PC3, PC4, 5, and 6. Okay. Now, let us move forward, right? And using this, let us calculate. Okay. Let us try to define the functions. Okay. And let us highlight the top three, which are mostly contributing in each uh, column, right? And with that, let us try to use these principal components and try to understand. So here you can see that there are certain elements which we have been highlighted. Okay. Now, let us go to the next part, which is the k-means clustering. Okay. So k-means clustering, actually, we have discussed what is k-means clustering and why k-means clustering is used. The little theoretical part we have already discussed in the yesterday's session as well. Right. So let us also understand that what are the drawbacks also before performing the k-means. Why we have actually applied PCA, you will understand. So if this is the basic problem, the problem is with the higher dimensions. Okay, so the curse of dimensionality is what haunts the k-means clustering. That is why I will never recommend k-means clustering without a principal component analysis, PCA. So first do the PCA, then you apply the k-means clustering, right? So this is a solution when you have to, apply the PCA. Okay. So I can just go through, anyway, we try to clear out the outliers and all those things. Okay. Fine. So this is what we are going to do. Okay. This is just an image to show you that how we can optimally build the clusters. Okay. So I'm just scrolling this down. Okay. Yeah, so let us go to the very important part which we have to discuss. So the elbow method and the Silhouette method. Okay, so these are the two methods which on that basis where the k-means clustering actually works. Okay, so let us see the elbow method. So why we call it as an why we call it as an elbow method is the graph shows in the form of an elbow. Okay, so where the elbow or the where the line comes down drastically as an elbow shape, that particular point will be your optimum clusters or the optimum number of clusters. So that you can identify using the elbow method. That is what the greatness of using an elbow method. So since the graph will be on the shape of an elbow, right, or your hand, which is your elbow, so that is where it is defined or it is actually given the name as an elbow method. So is it really is going to show like that? Yes, it is going to show like that. Okay, so that is the magic of using the elbow method for optimally clustering, the ideal number of clusters in the clustering part. So now let us go down. Okay, so let us apply the k-means elbow method. Let us visualize. Okay, and applying the k-means. So we are directly applying the inertia with the k-means plus plus clustering. Okay, so now if you see that this is how the graph looks. Okay, as the shape of an elbow. So now where how to identify basically is we have to identify the graph where the graph actually dips very strongly where it dips. So where it exactly dipping is around some 5 to 6, around somewhere like that. So let us consider 5. Okay, and let us go with the optimum number of clusters. Okay, but so see here, if you see, I'm not very satisfied. That is what I have mentioned in my insight as well. Here I'm not satisfied that much. So actually it is having a dip from this 4 to 7, maybe 8 also. So that is what I have mentioned in my, so I'm not very clear. That is what I mentioned, which is very common in the real world data. So sometimes a certain method might fail. Okay. So usually the elbow method is very good, right? But in this particular project, you can see that the elbow method is not giving you the ideal, I can say, with a lot of trust, I cannot say that it is 5 clusters, or I cannot say it is a 6 clusters or a 7 clusters or a, 4 clusters. I'm not able to say that, right? Because the elbow method is bringing in a lot of uncertainty in the data. So, let us go with the Silhouette method also, right? So Silhouette method is basically, I can say, it is basically a mathematical calculation. Okay, so same like, what happens in a inertia method as well. So let us, you can just go back to the theory part. You can just read what is the Silhouette method. So now let us focus on what happens in the Silhouette method. Now, let us go to the graph. Okay, so this is what we apply, how we apply the Silhouette score. So let me go to the graph. Okay, so this graph will actually show that where the data points are actually at the highest point. Okay, so this is a different way of visualizing. Okay, so so see, elbow method shows that where the graph dips. Okay, so where it dips, that the drastic dip in the point is basically your ideal number of clusters. But the Silhouette score shows you that where there is in the graph where there is a highest point. So if you can see in this, the highest point is at, or the highest Silhouette score is basically at the 4 cluster. You can see 0.240. So none of the other clusters are having the highest Silhouette score, which has, which 4 has. So that is why, see, if you see this graph, you may get a doubt that, the ideally the dip is at 4. Okay. You can see the same dip here also. You can say the same dip here also. So maybe ideally, if you want to select 4, ideally I want to select, but I feel very uncertain here because it's not directly dipping like this and going down. So it is like, going like this, not very, ideal way it is going, right? So that is why, we also every time when we build elbow method also, ideally I would also build, or not just me, also in the industry also, we are going to build the Silhouette score also to identify that what is the possible number of clusters which are actually possible, or which is the ideal number of clusters that can be formed. So then after that, we are going to plot with the total number of clusters what we have. So you can see that how the clustering can be done. If it is a 3 cluster, if it is a 4 cluster, if it is a 5 cluster, 6 clusters, 7 clusters, and 8 clusters, and 9 clusters, and we went till 12 clusters. So if you see, the Silhouette score should be more. Please understand this. This is 2-0, this is 2-1, this is 2-0, 2-2, 2-1, 2-1, 2-0, 2-0, 2-4, 2-4. So even 3 is also an ideal cluster. But if you see the graph, right? So it is also near 0.235. So it is basically giving, it is rounding it off to 0.24. This is rounding it off, but here in the fourth cluster point, this is directly 0.24. So you have to consider 4 as the ideal number of clusters. So that is the magic of using the, Silhouette analysis. So even though you're using elbow method, I would prefer you to use also the Silhouette to make sure that yes, I have plotted, I have got the ideal number of graphs. Okay. So just this part I'm skipping. Let us go to the, so yeah. So this Silhouette has actually given me the better insights. Okay. So here you can see, because 3 is also giving an ideal number of clusters, we can also choose 3, as well as we can also choose 4. So here you can see this, if you're choosing 3, right, it's clustered more properly than 4. See this, in 4, this part is very less, this part is also very less. So ideally, this is showing you this is a very good group, this is a very good group. Okay, but the graph shows here at 4, but this is also very similar. So that is what we have to put our brain and also understand that how things actually are working when we are putting multiple clusters. Okay, so now let us apply the k-means clustering to fit or on the clean data. Okay, so now let us go with the 3 clusters which we have got. Okay, so let me evaluate using the 3 clusters. So I'm taking 3 clusters, which is cluster 1, cluster 2, and cluster 3. Okay, so for these clusters, I'm trying to plot a 3D graph. Okay, so this graph actually shows you a 3D graph where you can plot the clusters. You can see the clusters, how they are plotted. Okay, you can rotate it in any way. Okay, that is why we actually plot a 3D graph. So we are plotting the graph with cluster 1, cluster 2, and cluster 3. Okay, this is 1, cluster 2. Okay, so you can plot this 3D graph and you can evaluate or understand the clusters. Now, if you have to see the distribution, okay, so of how much of customers are distributed across the clusters. Okay, so we can plot a bar horizontal, which we have done again here. Okay, somewhere we have given, yeah, orientation horizontal. So here we have, once we have done that, you can see that the cluster 0, it is 40%, 40.72, and 41.23 in the cluster 1, and cluster 2, which is 18.05. Okay, so these are 3 clusters. Okay, and this is how we are going to focus more on the first 2 clusters, particularly because it holds about 41%. So 82% of the customers are from my first 2 clusters. So I'll focus more on those people, which will help me build my business. Okay, so this is how the metrics can be evaluated. Okay, so just go through this Silhouette and clustering inference, what I've just mentioned. Okay, and you can just come up if you have any doubt in this particular project. Okay, this is how the clustering can be also done. Okay, this is basically a very detailed analysis what I have done, and I've given the colors. So first one is the red cluster. green cluster and the blue chart. Okay, and I'm plotting for the total transactions according to each column, right? The features what we have done with each cluster. So this is days purchased for cluster 0, cluster 1 and cluster 2, and this is again total purchase for cluster 0, cluster 1, and like that I have built for all the features what we felt is important. Okay, so based on that we can evaluate and we can make a conclusion that how the behavior of the clusters, right? So based on the clusters visualization, we can understand that what is happening in the cluster 0. Okay, and these are basically casual weekend shoppers, and cluster 1 is occasional big spenders, and cluster 2 is early eager bird shoppers. So this is how we have identified our customers. So this is how top products which we have identified. So this is what the data is about. So it's a very interesting data set, and very interesting project as well. Actually, I really like this project so much. Right? It actually tells you how things work in the online retail sector. Right? How people actually show interest, how their behavior is and all. So you can just go through this project. I'll share this project. You can just have a glance, try to execute using the dataset, step-by-step procedure. You can try to understand on what inputs I have given, so you can build upon that. So, ma'am, you can take over. It's almost, yeah, it's 9.
Yeah, sure, sir. Thank you so much. So, yes, students, we are done for the day. If you have any questions, you can ask it out. Like, so yeah, sir, we'll meet again by tomorrow at 7:30. So the session is starting at 7:30. As you all know, from today we are starting the session at 7:30 to 9. Okay. Yeah. Thank you all. Good night. We'll meet again by tomorrow. Thank you, sir. Thank you so much for the valuable class.
Okay. Sure, I'll share the project.